going to put a PowerPoint presentation up there that'll allow you to get a little more in depth with some practice questions and you know, just to augment your knowledge about it. So, starting off, what is electricity? Anybody got an answer?
Energy?
Energy, of course. Type of energy.
Kinetic.
It's definitely kinetic.
Kinetic, right.
Also
current, energy in motion.
Yeah, it can also be, right, it can also be potential.
Potential, right.
Okay.
But from a, I guess, scientific or Western scientific point of view, electricity is basically the movement of electrons in motion. What happens, you have what are called conductors, you have semiconductors, and you have what are called insulators. You have a cell, I mean not a cell, an atom. It's got a, you know, your nucleus with your protons and your neutrons that have, your protons have a positive charge, right?
Right.
Then you have out here your electrons with a negative charge. And if we remember from chemistry class, which I didn't pay a whole lot of attention to, but you've got different elements with different numbers of protons and neutrons and electrons. And it's all based on what are called orbitals. Okay? Each orbital is able to hold a certain amount of electrons. I believe the first orbital holds 2. Then the second orbital or ring or path will hold 8. So you got 8 out here. Then it goes on and on depending on how many electrons, how many neutrons are in that atom. Now they tell us that the number of protons and electrons should be balanced. I mean, if you got the element of oxygen, you got 8 protons and you should have 8 electrons to balance that little universe there. So what happens is you got some elements, particularly metals, that have in their outer ring only 1 or maybe 2 electrons. That makes them susceptible to losing an electron. Say a force comes along, say friction. You rub 2 things together and you get static electricity. Well, that friction, by the nature of it, helps to release electrons. Once you get enough electrons released and they have a path to flow, you've got a current. Does that make sense? So that's what happens if you look on your periodic table and you look at certain metals, they have 1 or 2 electrons in their outer orbital. Semiconductors may have 3 or 4, and insulators have 5, 6, up to 8 electrons in their outer orbital, which makes them very stable and very highly resistant to electrical current. Okay? Alright, let me see. Anyway, any questions on that? Okay. So the best conductors out there, gold. Very expensive though, that's why we don't have gold wires in our house. Silver will come next. I know platinum is up here too.
What about titanium? Boy, that's even more expensive maybe?
I don't think so. I don't think so. But I've never heard of titanium being a conductor. Yeah.
Copper.
Right. And this is the element that we most often find in our homes. In any industrial or commercial application, you'll find copper. Now there's another conductor that is used as well.
Aluminum.
Aluminum. Aluminum, like that ladder there. How you doing, brother? It's not as good a conductor as copper, but it's a lot less expensive. A lot of times guys who are trying to save money on the job, instead of going buy a copper wire, they're going to get aluminum. But you got to have a much thicker aluminum wire to conduct the same amount of electricity as a copper wire. And aluminum is lighter in weight, so it's easier to work with. All right, I'm just going to keep rushing through this here, because I want us to be able to spend most of our time in actual installation. A couple things to remember. We're talking about solar panels. So this falls into what we call
voltage.
Put an S on it. Photovoltaics.
Voltage. Okay. New word.
Photovoltaic energy. We break the word down. Photo is what?
Picture.
What do you need for a picture?
Light.
Light. Voltaic. What do you see in that word?
Energy.
Voltage.
Electricity.
Voltage.
Power.
Voltage. So that would be
Light power.
right. Or electricity generated from light, namely the sun. Okay. Kashawn, we have a eraser for this.
You know what? I give you a
Napkin or something. Oh. Okay. So yeah, photovoltaics. They're dealing with your solar panels. Before I go into the breakdown of the system, I want to talk a little bit about some of the units of measurement for the electrical field.
somebody's work.
Yeah, mine, but you can use it if you need to. Yeah, go ahead.
Anybody ever installed an outlet or anything besides changing a light bulb? No? Okay, cool. Well, you about to jump right into some stuff that guys who doing this 10, 20, 30 years have yet to touch on.
Okay. Quantum leap, huh?
Quantum leap, we're making leaps and bounds.
My man.
All right. Now, let's talk about some basic units of measurement. I just mentioned voltaic, so we'll start with the volt. The volt is the basic unit of measurement to measure what we call voltage. Okay. Voltage is in the, well, let's keep going first. Then we have, it's called an amp. Anybody heard that before?
Mm-hmm.
Amps measure amperage.
Amperage.
Ohm. Anybody know what an ohm measures? Impedance is, right. Impedance is a form of resistance. Okay. And lastly for this discussion, watt. Watt measures power. Okay. Now let's liken our, well, okay, let's talk about circuit. Yes.
What's the difference between voltage and power?
We're about to go into all that right now because they're all interrelated.
Okay.
Circuit is path for electrons to flow. Source of power, and most often, well, you're going to have a load, like a light bulb, and you're going to have, sometimes you don't, but most times you'll have control means, i.e. switch. Load could be, say, a light bulb. Source could be a battery. Path could be a piece of wire. Okay? All right, let's start at the top. Voltage is measuring the pressure that's being applied to the circuit. I'm going to give you a good analogy in just a second. Amps measures the intensity. How many electrons are flowing? Voltage is how much pressure is pumping those electrons through. And every circuit has resistance. Even a highly conductive material will have some resistance. So resistance measures the resistance to electrical flow. That's why you find your wires will be insulated with, most times now, some kind of thermoplastic type of material, which is highly resistant to electron flow. Okay, now let's use the example of a water spigot. Okay, you've got this pipe here. The voltage will be equal to how much pressure. So the more I open this up, the more pressure, right?
Mm-hmm.
So the more pressure, that's the more voltage we got. Okay. The amperage, or the amps, will be measured by how much water is coming out. That makes sense? Okay. Real simple analogy, and sometimes I'm telling you, it took years for this to click to me. Even though with that simple analogy, it took years for me to understand the difference. And watts, simply power, which is the amount of work that's being done by the electron. Most times you hear watts being expressed in terms of light bulbs. I need a 60-watt bulb or a 100-watt bulb. That's because that electricity flowing in there, it heats up these filaments which give off light. So that electricity is being used to give off the light, and it's translated as power, and we measure that in watts. Now, talking about solar, very important unit to keep in mind is the watt hour. Because when we're sizing a system, we want to know, first of all, what do we intend to power up? What do we intend to power up? How many watts is it pulling? How long are we going to use it? Right? Okay, so now there's some equations here that are good to remember. Watts equals and I is used for amps, intensity. Power equals volts times current. Okay? Now, when you go home, something for you to do, look on your toaster. On the toaster, there should be a nameplate rating. It tells you all the electrical information about it. It tells you, a lot of times it'll give you watts, most all times it'll give you the volts, and sometimes it gives you how many amps. It may say 2 point whatever amps. Okay, say for instance, it doesn't give you amps, but I need to know the amps for my whatever I'm doing. I'm in there troubleshooting. I need to know how much load is on this particular circuit. Say it only gives me the watts. Say it says it's 2,600 watts. Well, I know this is a 120 volt circuit. And one thing to keep in mind, inside our homes, you got what's called nominal voltage. Nominal voltage is what's coming in. That's the name that we give to it. That's what it's supposed to be, if that makes sense. Nominal voltage. In any residential, you're not going to have more than 240 volts coming in. Single phase. I know this. I'm just throwing terms at you now, but single phase, which means that you're going to have coming in, say that's one wire, that's one hot wire, this is another hot wire, then you have what's called the neutral wire in between. And the neutral, maybe I'm getting too deep, but the neutral carries the unbalanced load between these two back. That's getting into AC theory and DC theory. Okay? AC means alternating current. Mm-hmm. That means the current goes this way in a wave, then it comes back this way. DC is straight. Battery is DC. It's straight current. There's no alternation. There's no neutral wire. Okay? And to give you a little history on it, DC current was being promoted by Edison and his crew back in the day. He was trying to get everybody on the DC. It was a man by the name of Nikola Tesla who introduced the AC thing.